This graph illustrates the standard metric for AI success over the last several years. Each new model release was measured by its ability to push the line on standardized intelligence benchmarks, climbing in steep vertical leaps. But with the release of Claude Opus 4.8, Anthropic described the model's benchmark gains as merely incremental. This plateau isn't a sign of technical stagnation. Instead, it suggests the industry has reached a point of diminishing returns for raw intelligence alone. The primary bottleneck for developers has shifted. The models are smart enough to perform the tasks, but they have lacked the operational endurance and predictability needed for production-grade applications. Moving AI from a research curiosity to a dependable utility requires a shift in focus toward operational control and long-running reliability. To see why that control is so necessary, we can look at the specific friction points found in the previous model, Opus 4.7. Much of the community backlash centered on adaptive thinking. As this flowchart shows, user input entered a black box where the AI decided its own reasoning budget. The system branched into unpredictable paths, stripping developers of the ability to dictate processing power. There was also a financial barrier to long-running work. In older models, updating instructions mid-task often broke the prompt cache. This forced the system to reprocess the entire context, causing users to pay for the same data twice. Anthropic recognized that these rigid caching structures and autonomous reasoning budgets were preventing the model from being used for multi-day enterprise projects. Opus 4.8 addresses these issues by removing the forced adaptive thinking feature. Developers now have manual toggles to set the precise thinking budget for a task, ranging from low to max. A new Messages API also allows developers to inject new system instructions directly into a task while it is still running. This animation shows the economic result. Developers can now steer the model midstream without breaking the prompt cache, keeping the cost counter low even as the task evolves. By returning this level of computational and financial control to the user, the system becomes viable for larger, unsupervised jobs. These technical updates provide the foundation for a new execution pattern called dynamic workflows. In this mode, the AI moves beyond responding to individual prompts and begins acting as an automated project manager. A clear example of this is the recent migration of the Bun codebase, moving a complex software library from the Zig language to Rust. A developer assigns a unified task to the Opus 4.8 orchestrator. It writes scripts to break the objective into fragments, launching hundreds of parallel subagents. Each agent runs unit tests, verifying its code before returning data. This massive migration achieved a 99.8% pass rate. Opus 4.8 effectively transitions the AI from a tool that answers questions into a manager that directs a digital workforce. Sustaining these agent-heavy workflows requires a pricing model that can handle the massive token volume generated by constant sub-agent communication. While other labs have begun raising their usage costs, Anthropic has taken a different approach to its API pricing. While competitor costs rise, Anthropic held their baseline steady and made their fast mode 3 times cheaper than previous versions. This predictable pricing is the practical requirement for businesses looking to scale these large-scale orchestration workflows. The release of Opus 4.8 reflects a transition in how we build with these models. The strategy of relying on one perfect prompt to solve a complex problem is becoming obsolete. We are moving toward a model of asynchronous project management, where AI operates in the background for hours or days to achieve a verifiable goal. The future belongs not to the labs with the smartest chatbots, but to those that can provide a controllable and tireless digital workforce.